Hi everyone, in this video we're going to be discussing the conditional operator. Now I might call the conditional operator by a few different names. I'm usually just going to call it the conditional, but sometimes I might call it something else. Its formal name is the material implication, but I might also call it by the name of the symbol which we might use, which is the horseshoe or the arrow. But I probably will just be calling it the conditional operator. So yeah, I just wanted to say that. So like everything else we've been doing, we're going to show the relationship between two statements. I'm just going to use P and Q for our two statements. And we're going to give them the two truth values. So we have P and Q, which is two propositions. So in total we're going to have 2 squared, which is going to give us 4 truth values, half of which are true, 1, 2, and the half of which are false, false, false. And we're going to do the same thing with Q. We're going to get half of the 2 true right here, which is going to be 1, and then half of the 2 false right here, which is going to be 1. We'll maintain this pattern, true, false. We have 2 true right here, 2 false right here. That shows us we did it correctly. Now what's this operator that we need? Well, the horseshoe kind of looks like an arrow pointing to the right. So I'm going to write that in Microsoft Excel. Now because Excel, and I don't know about the other programs that are recommended like Google Spreadsheets or OpenOffice. OpenOffice is Excel equivalent. I forget what it's called, but they don't support I don't know, dashes really well, so you have to kind of put in a bit of effort. So to do this, we draw an equal sign and then open quotations, and we put a dash and then another dash and then a greater than sign and then close quotation. So that's how we do it. I'll just give you a quick example of what happens if we don't do that. So I'll just put dash dash greater than arrow. So we get this error right here. So I'm just gonna hit OK. If you don't mind getting errors, then you can do that. Well, actually, I think even if you do that and you get an error, yeah, you're still gonna get an error. It's not gonna let you enter it in there. So I'll just delete that. So that's the way you enter it in. Again, equal sign, open quotation, dash, dash, greater than arrow, close quotation. So now, what's the relationship between P and Q? Well, if P is true and Q is true, then we get a true right here. So I'll just give you a quick example of that in a statement. Let's say we have a relationship if P then Q. If it's snowing, then I won't go to school today. So if it's true that it's snowing, then it's also true that I won't go to school today. Now this statement right here is pretty easy to understand too. The statement also relates with a principle that we haven't talked about in logic, which is called validity. So in logic we say that an argument is valid if it has true premises and a false conclusion. And again, I'm using a bunch of terminology that we haven't talked about yet. We haven't talked about what an argument is, and we haven't talked about what premises are. So I'll start with premises since it's a bit more foundational. So a premise is any statement which supports a conclusion. And an argument is comprised of at least one premise and at most one conclusion. So an argument can have like a million premises, but it can still only have one conclusion. So an argument is only valid if it does not have true premises and a false conclusion. So the formal name for both of these terms, this term on the left is called the antecedent. This term on the right is called the consequent. But let's say if this premise, let's call it a premise for now. That's not the formal name. Remember, it's called the antecedent. But let's just say if it was a premise and it was true, and the consequent was false, that wouldn't make any sense. It wouldn't make any sense if it is snowing. If it's snowing, then I don't go to school today, and it's snowing, but I still go to school today. That wouldn't make sense. So we say when we have this relationship true and then false, we get a false right here. This relationship's a bit tricky. Not P then Q. This one I've always kind of been confused about. It's actually true, even if P is false, and that Q is still true. And I guess this goes back to the whole validity principle, which is that an argument is always valid unless it has true premises and a false conclusion. And so again, that's why this one's false, and in any other circumstance it remains true. And so this, as far as this last one goes, this last one is true because certainly if I'm going to school today, if I'm going to school today, or if it's false that I don't go to school today, which means that I'm going to school today, then it's also false that it's snowing, right? Because if it was snowing, then it would be true that I'm not going to school today. So again, this is also true. And so that's the relationship between the implication operator, or like I said, the conditional. So let's do one more example that's a bit more complicated. So we'll do P and Q, and we'll draw our little arrow right here. I'm just going to use the equal sign right here, and then go back up to where my arrow is. Then I'm going to hit enter to copy it, and then we'll draw P or Q, then R. And again, now remember that we have 3 propositions right here, so we're going to get 2 to the 3rd power, which is going to give us 8 propositions. So we're going to get half of those true, 1, 2, 3, 4, and the rest false, 5, 6, 7, 8. Then we're going to jump to Q and then get half of however many we had before, which is 4, so half of that's 2, and half of the false, which is also 2. So that's 1, 2, 3, 4, and then we maintain that pattern, so 5, 6, 7, 8. Then for R, we get half of however many we had before for true, so that's, we get 2, and so we get 1. Then we get half of however many false we had, so we get 1. And we maintain that pattern, true, false, 3, 4, 5, 6, 7, 8. Okay, so again, we start with the things inside the parentheses. So right here, the AND operator is only true when both of its conjuncts are true. So right here, they're both true, so we get a true. Right here, they're both true, so we get a true. Right here, the Q is false, so we get a false. Right here, the Q is false, so we get a false. Right here, the P is false, so we get a false. And if we notice, for the rest of the conjunct on the P side, they're all false, so we just give it all falses right there. So this is the truth value for the conditional. Now again, this AND operator is the sum of the truth values of P and Q, so it's the main truth value for the whole thing. And so we're going to just highlight this to kind of show that it's a combined truth value. But then this R is standing alone by itself. So we're going to highlight this R the same color to show that it has a relationship. This conditional is showing the relationship between this R and this P and Q. So now using this truth value right here of the AND operator and this truth value of R, we're going to get the truth value right here of the conditional. So remember, the conditional is true whenever you don't have true antecedent and a false consequence. Right here is the only time when it's false. So right here we have a true, right here we have a true, so we get a true. Right here we have a true, and right here we have a false, so we get a false. Right here we have a false, and when the antecedent is false, this side on the left side, when it's false, it's always true. So if we scroll down, we can see that it's all false right here, and so that means that this conditional right here is always true. So you can just write true, 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 true. So I don't know if I emphasized that enough. So I just want to show you on these last true, we have a false and a true right here. We have a false antecedent right here and a false antecedent right here, and they're both true. So whenever the antecedent, the side on the left, is always false, the truth value of the conditional will always be true. It doesn't matter if the consequence truth value is true or if the consequence truth value is false. If the antecedent's truth value is false, it'll always be true. And so that's why for these last 6, they're all false, and for these last 6, they're all true right here of the consequence. So here's just a quick overview of how the conditional operator works, and I'll see you guys in the next video.